Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called binary tree maximum path sum. A path in the binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. So like in this graph, 1 and 2 forms a path. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. Okay, so we can have multiple paths, like in here, we have one path here. Okay, it doesn't need to go to the root. So the path sum is the sum of the node's value in the path. And we were given the root of a binary tree, return the maximum path sum of any non-empty path. Okay, so this is pretty straightforward. Let's take a look. So we have this tree rooted at 1. So the output would be 6 because we're combining the left subtree, the right subtree, and the root. So this is a valid path. Okay, and for this one, for this tree, we can see the maximum path sum is here for the right subtree of the root node. And how should we do this? Okay, so first, we have to make sure that we're using a variable max to store the final result. Okay, and we're going to traverse the tree. I think it's better to do it in a DFS manner. So when we call DFS on the root node, we go to left, we go to right, and we update the current left max and right max. So what we're going to return to the parent node would be either left subtree or right subtree, because we're forming a path. If we return both sides, it will not give us a path to the parent node. Okay, so if we're calling DFS on -10, which is the root, and we go to right, we call another DFS here, then it will go left and right, but the return value shouldn't be this path, because if it was a valid number, we cannot form a path containing 20, 15, 7, and the root node at the same time. Okay, we have to return the max path. So here, in this example, it will be the left subtree. Okay, so if we have a maximum path going through the root node, it will be like this. Okay, at least the right part. It will be like this. So return to the parent node, we're going to return the max value of left max and right max. Okay, and we can update the final max along the way, along the traversal, by calculating left max plus right max plus root dot value. Because we can end at any time. We don't have to go through the root. Okay, so we can update it like this. And I think that's pretty much what we have right now. So yes, there's one problem here. So what if our return value is a negative number? Should we return it as well? I don't think we should return it. We should just return 0 instead. Okay, so if we have something like -11, -1000, should we return anything? No, we should not extend our path to the negative nodes. Okay, so we can simply return 0 by not selecting any of the negative numbers. Okay, so now if that's clear, let's code it out. First, we will use a max sum, okay? Integer mean value. So we're gonna use this to record our final result. And for the main function, if our root is null, we have to do the null check, return 0, and we call on the DFS, and then we can return the max sum, okay? And here's the DFS, root. So if still root is null, return 0, and we can call on the left max, okay? Let's just call left. DFS root dot left, right equals to root dot right, okay? So what about the current level? We are going, we're going to have a return value, which is the max of the left and right, okay? So also we are going to return this with our root value, okay? And if return is larger than 0, we'll just return it. Otherwise, we can just return 0. And remember, I said we will update the max along the traversal. So max sum will equal to math.max, max sum left plus right plus root dot value, because we can end at any time the path, right? Okay, that's basically how we do it. Let's try. Okay, I think it passes the test cases here. So let's analyze the complexity. For complexity, we have to traverse through all of the nodes in this tree, right? And for space, we're calling DFS, so it's basically O height. And in the worst case, we can do ON, since like we have a highly tilted tree, highly imbalanced tree, like a linked list, but it's still O height. Okay, let's submit it. Okay, it passes. Thank you so much for watching. If you like the video, please like and subscribe to my channel. I'll see you in our next video.